Hello! Today we're going to try to derive a formula for the number of diagonals in a polygon. In other words, what conjecture can we make about the number of diagonals from one vertex in a polygon? After that, we're going to try and summarize to find the total number of diagonals that could be drawn in any polygon. We're going to start with the simple figure, which is the triangle. A triangle has three sides. As you can see from the drawing, the total number of diagonals from one vertex is 0. The total number of diagonals is also 0. In other words, a triangle has no diagonals. The quadrilateral has 4 sides. From each vertex you can draw only one diagonal. So for example, if you concentrate on the orange diagonal from the top vertex, you're going to see that from one vertex we draw only one diagonal. The total number of diagonals in a quadrilateral is 2. The next figure is the pentagon. If you concentrate on the top vertex and see the dark orange diagonals, you can conclude that from one vertex in a pentagon we can draw 2 diagonals. If you can count the one in blue as well, you will see that the total number of diagonals in a pentagon is 5. It's easy to make a mistake and think that if there are 2 diagonals from each vertex, 5 vertices, the total is going to be 5 times 2, 10. That would be incorrect because as you go around, you will count some of the diagonals twice. The hexagon. The hexagon has 6 sides. As you can see again in dark orange from the top vertex, from one vertex we can draw 3 diagonals in a hexagon. If you can count the ones in blue as well, the total number of diagonals in the hexagon becomes 9. The last figure we're going to see is the octagon. The reason being it's hard to see the diagonals here and it's hard to count them, but if you concentrate again on the top vertex, from the top vertex in dark orange you have 5 diagonals, and if you can count the ones in blue and add them to the ones in orange, you're gonna have a total of 20 diagonals. So let's summarize. We have a table here. The first column is the number of sides, the second column is the number of diagonals from one vertex, and the last one the total number of diagonals. As you go down the table, you can easily see that the number of diagonals from one vertex is always the number of sides minus 3. In other words, n minus 3. The total number of diagonals, keeping in mind that we have to use this n minus 3, is n minus 3 multiplied by n divided by 2, where n again is the number of sides. I hope you enjoyed this presentation.